All right, let's get it. Study part one, or part one study, I guess is what we say. I don't know. More template shit. So last time we learned about template, function templates, function template specializations. Got to wipe the glasses off. Specializations, so we can explicitly create an instance of a function, and we use the angled brackets to specify the exact type, and then we replace the parameters in the return type. We replace the template's type name with instead just the explicit type that we're thinking. So we don't just put int in the angled brackets and then leave everything else the type name shit. We instead explicitly put it all that, and then we leave the little template piece as int or whatever, the same type. That way the compiler knows, hey, you're not just overloading this function and you're creating an overload, you're actually creating a specialization of this template, I guess, so it doesn't generate it, but it seems like it wouldn't generate it anyways if you had it. I'm not really sure the value of that right now. Same way with making a template clause for a primary template, and then just calling it straight up. It also works in updates, so I'm not really sure the value of specializations right now. Well, I mean, specializations, I guess I can just specify different logic, but I'm not really sure why I would call the primary template with the parameter. I mean, I guess no, it seems like it's redundant. I'll show you what I mean. Alright, so the fuck? Hair's stuck. Alright, now we're good. Okay. Oh, also got promoted today. Let's fucking go, baby. Making 58,000 instead of 50. Moving up. Slow. 1 year left, and then we'll be doing some real shit. Indie game dev. Let's go. Alright, so what am I doing? I don't need IOStream. We're gonna do a template here. So we're gonna do template, and we'll do some type name T action, and then and just to explain the point, we'll do type name TS. Was it STQ? TU. Oh, U is after. I don't like that. I like Q, honestly. I like T and Q. I don't know why. So we'll do return. We'll just say avoid, but then do thing, and then it takes a TX and it takes a QY. Excuse me, and then a Y, and it doesn't return anything. So cool. So we have a void. I mean, we have a void returning template here, and it can generate other function instances depending on what the actual parameters of X and Y are, i.e., what data types T and Q are. All right. So now I could call do thing and then call it with. It could be the same type. We could say 3 and 3 or 3 and 5 or 4. Okay, it's fine. These can be the same type, T and Q, but they could also be different types. So we could just say 3.0 and 3. Okay, well now T is a float in this instance. So we can look at the signature. And this is the signature. So this is showing you the specialization that is being generated. And I think, what do they call them? You call them specializations. I'm just going to call them specializations. Sure, it's like the template overload, kind of. It's the instance of the function that it generates for this type. And in this case, in the little template spot, right? Fuck. I don't have a second cursor, but the after do thing, the angled brackets double and int, that right there shows that, hey, this isn't just a straight up overload, which is if this was just int and this was, or this was double and this was int, and it was down here, like, well, fuck it. I mean, I'll just copy real quick. So we could do this and then say double and then int, and it's actually still fine. We're calling an overload, we're not calling a specialization. If we remove this guy, we don't see any overload shit because we're calling a specialization. And I could explicitly make a specialization. In order to make a specialization, we have to do this template little like continue previous template. And then we could say, and I think this is saying, hey, look for the existing template that takes, well, we don't even have to put T and Q here, but in it, it'll have, well, I'm not actually sure which one this would get. I don't know. All right. And then we could have void do thing, but then we could put in, we could do double int and then double x int y and then x y. And now we've made an explicit specialization of this guy. And I guess it's registering as an overload because it's this additional function beyond the primary template, something like that. And I might do that because let's just say both of these return an int. Well, let's say in all other instances, I want x, y, just so that we're using them, and then we just return 3. Okay. But what if when you use a double in an int, I want to return 4? Well, it's fine. That's cool. In this case, it's going to be returning 4 right here because we're using a double and an int. We're not, we're calling the explicit specialization. If this didn't match and we called 3 and 3, this is not a double and an int. There's no match here. It calls this guy, and then it would generate another specialization that would be int. And we can test real quick. Well, let's say why we need it. Oh, what the fuck am I doing? Okay, and then we can just do cool. Yeah, so we're calling this guy, we're getting 3 because there isn't an int specialization, but if I just add a point, boom, now we get 4 because we're calling the specializer, or the explicit specialization. Okay. Okie doker. What else? I think, yeah, I didn't update this last night. Maybe, did I finish it? I thought template parameter declaration. How far did we get? I got past here. There's no difference between the type name and class. Yep. Naming template parameters. Yeah. Capital. Yeah. T allocator. Yeah. Okay. Oh. Yeah. Wait, I explained this last night. Yeah. The whole point is a construction blueprint is a way of doing the same thing, the same general plan, the template, but the specific implementation, the exact result, the exact house that you're going to get depends on the materials that you provide me, how much money you give me. In that case, are you paying for the granite countertops? Or are you doing the cheapo stuff? We can do it with the cheapo stuff. I'll put my template on the cheapo stuff and you get a cheapo house. I can put my shit on an expensive stuff and you get an expensive house. Okay. That is why we have this template that does some shit and it generates matching specializations, little function overloads from the template that we don't have to manually create, but we can manually create if we want the behavior from one specialization to differ from the others that are generated. Okay. Did we get this far? I think I did. Yeah, we saw this earlier. Okay, we did not get this far. Yeah, okay, we got this far. I remember this sentence. All right. So, what were we doing? Oh, yeah, we made a template for Max. So do template type name T, because we only want one type name, because we only want one data type. We're comparing two of the same type of things. And we'll just say a T. So if we're comparing doubles, we return a double. And we'll just call it max. And we'll say a T X and a T Y, because we're comparing an X and a Y. And we are returning, is X greater than Y? If it is, then return X. Otherwise, return Y. Cool. And then we could call oops. What the fuck? Okay. Don't like this keyboard. Excuse me. 3 and 4. Okay. Boom. We could do huge numbers, or we could do 4.0, 777 point huge numbers. Okay. All right. Which one is the max? I could also do 7, but then guess what? Oh, this guy's only generating function instances, specializations with identical types. Well, these are different types, so it won't match. There's no matching guy to call. So normally it'll say, hey, 4.0 and 7, there's a double and an int. Okay, is there already one that exists? Nope. Can you generate it? Nope. Well, can't do it, buddy. No function for you, bucko. And max is already a thing. So if I just didn't have max, then it's just undefined. But we do have max, and it's looking for an overload, another version that has two different types. If we did max type name T, and then type name Q for another type, and then we said Q, and we return, well, I mean, this is interesting. I mean, I guess it's cool. The point is that it would be converting the Y to a T. So let's say, so Y is an int, this is a float. So it's going to return, well, it's not going to, well, it's not going to, it's going to say 7 because standard character output kills trailing zeros. But it's returning a double type value. Because we're passing this is a double, so T is a double, so we're returning a double. But really this is returning 7.0. It's just that we're not seeing it, which is fine. And the point here, what? I mean, that's just how you use it. Oh, fuck. Yeah, I was actually calling it wrong. Really what we want to be calling is we want to say what these type names are. Why? I'm not really sure yet. I can call it like that and say, boom, okay, we get that. But I could also still just remove this and let the compiler figure out, hey, we're calling a double in an int version. Does it exist? No. Okay, create it. Template. Instead, we could also say, hey, a double and an int, and it'll say that, instead of it having to intuit what types these are. Maybe it's just more efficient because then it'll say, hey, double, boom. Instead of having to look and maybe evaluate a function and evaluate this and this and this to finally get the value that has been converted and done in this, just to finally see, oh shit, it's a something. And then maybe that something isn't even applicable here, but it still maybe did those calls to figure it out. Like, what if we had, int test, and then we just say, we call it, and it just returns 8. Or let's do some stepwise shit. We do test, and then it calls test 1. And then int, or well, and this is a void. Well, this needs to return. Nah, fuck it. We'll just have some nested return shit. Int test 1. Return 1. And this is return. Okay. So the point is now we're going to be calling test 1. Or sorry, we're going to be calling test. And let's see what happens here. So if we remove max, I'm guessing that it might be the case that the compiler has to see what is happening here and what this returns, but then this calls and then what this returns int to this. So the point is this, we're calling test from main, it returns an int. Eventually this shit's gonna return an int. Let's just do this real quick. We're gonna step into, wow, it actually does. So yeah, it calls test and then it calls test1, all just to finally return 1 and then 1 and then we call max. Well, I mean, that's going to happen anyways, actually. We don't know when in time max... Well, it's trying to call max, so I'm not sure, actually. I was hoping that just passing double and int will make it automatically create that, but I think it's created at compile. Yeah, that's the point. The point is that the compiler is doing it. So the compiler realizes, hey, this guy is this is this type, this is that. And the point is that the types are already known. There's no, like auto. Yeah, you can't have like auto with no initializer and then we initialize it with user input. And so depending on what the user inputs, that changes the type. But then the compiler doesn't know what type, therefore then the template doesn't work. Because the template is used by the compiler. The compiler will say, hey, Mr. Template, generate a specialization for this. Because we have a function call and it uses data type this. In this case, it already sees that test is called, which returns an int. So it doesn't matter what the fuck else happens. The point is that this guy is an int. So we have an int and an int, generate this. And I don't even have to call I don't have to call this or do anything. So never mind. So it seems like that supports my case that adding in int here, I mean, shouldn't help. I mean, maybe it makes compilation faster, but I mean, I can't see that being the case. It closes it and replaces it with the actual type. Okay. So the point is we call it like that with the explicit type specified. And if we don't call the function template, well, the function template doesn't have to make anything. Makes sense? It will not be instantiated. So in this case, yeah, we call max int bop bop and we return 2. Okay. And then for 3, oh, well, that template already exists. So, well, actually all of them. Well, it's not like this is happening at runtime. It's not like, hey, at runtime, then this happens, then it creates the function live. It's at compilation. It sees this first and then says, okay, we need an int template, or we need an int specialization of this primary template. Create the int version. Okay, ready to see the next one? Oh, look at that. We already have an int one over here. Oh, a double one. Oh, so we need one. Well, we're gonna have some implicit conversions happening into double, so it should be okay. Yeah, because double has the memory for it. So we're gonna need another one for a double. And it could also be the case that we want to put in some arguments and convert them to a different type and run them a different way. So maybe I have a function that does, like maybe I have a function that operates on doubles. And I call it and I do a bunch of calculations and shit with it. And later on I have some values that are very important, but they have to stay ints. they can't be doubles. I can't just go and change the fucking data type of this shit just to call this function. Instead, what I can do is in the call, I can specify what type I want them to be converted to instead of just passing them and then it's calling the int version, the int specialization, because my parameters are integers. Instead, it'll call the double version, but implicitly convert the doubles to become integers. That's kind of cool. Yeah, so it creates double, even though these are not doubles here. Excuse me. Yeah, so after those instantiations, it would look, if we're doing the max guy, we'll just do type name T, sure. And then we'll just say returning a T max, and then a TX and a TY. And then we just simply return, is X greater than Y? If it is, return X, otherwise return Y. But then we also can have template double max, well really it would be int max, max int X, int Y, return X is greater than Y, or we'll return if X is greater than Y, X, otherwise we do Y. And then another for double max double X, double Y, return X is greater than Y, return X, otherwise return Y, and main. And then we could say, hey, call whatever. Let's get some standard character output going, and then we could just say, we're gonna output, we're gonna call max int 1 and 3, and then we're gonna say same thing for max int huge number, something smaller, and then finally we're gonna output max double, and then we're gonna say the same shit, 1 and 3. Okay, and so we're saying compiler sees an int call to the primary template, so it instantiates an int specialization, and then already has an int specialization and uses it, and then compiler sees a double call to primary template, so it instantiates a double specialization. Cool. And then boom. Oops. It's true. I need an inline. That was stupid. Alright, yeah, so we get 3, and then we get a bigger number, and then 3 again. Cool. And the reason that the double one didn't have trailing 0 is because standard character output removes trailing 0. Oh, and maybe as proof, well, if we say 3 divided by 4, that's just going to be 0, and then that's going to get converted, and then it's going to say, right, I mean, I could say this, and then we'll just say 3 over 4. Like that, and 3 over 4 is going to be 0, 0. Yeah, it's fine, damn. Alright, well, there's no way to do it. You'd have to convert it afterwards. You'd have to convert first, and then do something to it once it became a double. Because this is evaluated first, and then they're converted to be doubles. So if we converted them to doubles and then did some arithmetic, we could see, oh, hey, these aren't actually trailing zeros. This is 5 over 3, which is whatever the fuck, 1.6 or something. So this works similarly. Cool. We have to generate two functions, and the reason is because we have two different type calls. Yeah. Yeah, makes sense. Let me do the template guy to continue it on. When we instantiate max double, it has parameters of type double. Yeah, implicit conversion. Yes, exactly. In most cases, the actual types are like that. Yeah, int. In that call, we specify we want to replace it, but we're also calling it with int arguments. So, in the cases where it matches, we do not need to actually specify it. We can use template argument deduction. Exactly. I think I might have even called it that yesterday. Maybe not, though, but I said, yeah, there's probably some sort of deductive process by which the template or the compiler says, hey, there's its primary template here. Okay, cool. It has one type name. All right. Oh, look at that. The user is calling it straight up, and the parameters or the arguments are of type float. Oh, they probably want a fucking float value. They probably want those values to stay floats. They probably want to generate, and they probably want to call the float specialization of the fucking template. Yeah, that's true. So in the event, in that event, we probably don't have to specify that. Hey, what's a good example in real life? It's like waving to someone and saying greetings at the same time in order to tell the person that I am not being or it's like seeing someone seeing a buddy for the first time in the day and waving like this and saying greetings. Motherfucker, I'm already saying that. Why am I saying it again at the same time? That's the greeting right there. He's not retarded. He's gonna know, oh, I haven't seen him yet today. He probably means not goodbye. He probably means fucking greetings. He probably means this is the template. Oh, he's jiggling the doorknob and he's pulling the door. Oh, he probably wants to come into the house. We don't need a dialogue box to pop up and say, do you want to, are you sure you want to enter the house? The fucker, he's already doing that, bro. Boom. That is why we have template type deduction. Or template argument deduction. Because we are creating a specialization of the primary template using argument type deduction. We're saying, hey, these are the argument types. One's an int, one's a float. We have a primary template that has two different type names. The user, he probably wants an int and a float specialization. Probably. Maybe not. Maybe he actually wants a double-double. So we have to implicitly convert that into a double. Uh-oh. Well, that's actually fine. Maybe that's not the case, though. All right, I've been, like, leaning over here because I want to close the blinds and turn the light on so I can stay awake. All right, because learning makes me tired. Oh, what? Oh. All right. Couple push-ups real quick. We'll do 15. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, and then we'll do 2 one-handed on either, well, 2 negatives on either side, so I'm not fucking myself up. 1, 3. Oh, 4. Oh. Okay. Just probably start doing negative one arms again so I can start doing one arm push ups and stuff. Okay. Alright. Yeah, template argument deduction. Yes. What types should be used in the call? What? So what happens if we have... Is it... So if we have a template, and then we have empty lines, and then we have this guy, is it basically just saying, hey, go up, excuse me, and get the last template, so A, i.e. if this is B template, does this then mean go up? Bro, nobody uses caret. What even is it? It's capital, or it's 6? Who uses that? Go up, and this is template for B. A specialization for B. Why the fuck would I call it like this? Why would I do that? Let's do half the effort. It's like, let's say, gree instead of greetings. Like, bro, either go full retard, go full redundant, or just be cool. Makes sense? Yep. Hold on, let me reread this. Wasn't locked in enough. We haven't provided a specific type. We haven't said, hey, do this specialization. Instead, it'll pull that information from the actual type and generate a max function where they match. So it will deduce it. It will say, oh, here's some shit. Let's create a pattern from the data. The data in this case being the arguments. It says, hey, I see a 1 and a 2. Those are 2 integers. We're going to create the int specialization. And thus, it will be int specialization part, int. Okay. Cool. The difference between these two, you mean? 1 and 2? Oh, yeah, here we go. The difference between the 2 cases has to do with how the compiler resolves the call from a set of overloaded functions. So, meaning, oh, is it saying that, hey, if we also have another max? It's like, if we have, if we have a max primary template, and then a max regular overloaded function, but then I call max angled brackets, does it then ignore the overloaded function and then say, hey, motherfucker, we need an int special, or we need a whatever specialization that matches these arguments. I don't want to call the overloaded one. The empty angle brackets, it will only consider those template functions when doing it. Otherwise, it will consider non-template overloads. Meaning, if we do, we get a little function action going on here. Let's get a little bit of music going too. What am I doing? Oh, this will be fun. This could be cool. Could be cool too. What do I want? Yeah, we'll do music. Yeah, that'll work. Am I retarded? Yes, I am. I wear glasses, I become dumb. Are we going to play? Oh, yeah. That's perfect. Okay. All right, so we're going to make a little primary template action. Template, type, type name T. What happens if we just do type name nothing? Type name T. And then we'll just say avoid something. We'll just say do thing. I like do thing. And then we have a T something. Okay, cool. Oh, sorry. And this is, oh yeah, this is fine. And so far it doesn't have a definition. This is just a for declaration is what it's saying here. Yep, no definition. Oh, I wonder how that works for function declarations. I don't know. How did we do it for overloads? Oh, well, for default arguments, we had to do it some way. But this could be interesting. Okay. Make sure no copyright action. Nice. Okay, we'll just say whatever X and then... Yeah, I'll just debug to watch what's happening. And then we'll do another, we'll do void do thing. But, wait, what? What are you complaining about? Oh, I accidentally did a for, oops, I accidentally put the semicolon. That was stupid. What are you saying, bro? And then we could say void do thing int x. What's happening here? Oh, well, oh, template, boom. And this guy is saying, what do we call this? No name for it? So we're saying, hey, continue, whatever the fuck. This one's gonna do this. But then we can still also have void do thing int x. Oh, and it's okay. Because this is the template one, and this is the other one. Whoa. And the relationships between these are, there's a shared identifier, but this is a template specialization, explicit specialization. This is just an overload? Excuse me. Interesting. Well, yeah, it can be made static. It's only being used in this file, bro. Okay, and so I could call do thing one. Okay. Calls non-template overload. And then I could do thing this guy one. Calls template overload. But then I could also do same thing. Calls template, specialization. But with specified type. And in this case, we could say this too. Never mind, because we have truncation action. Or, well, I guess we could say, in this case, we'll just say double, sure. Tells compiler to make double specialization and calls it. Cool. Nice. And now we can check. All right, what is being called? Well, look at do thing one. Check that. It's the last one. Yep, the non-template overload. Then this one is the explicit specialization. Cool. And the reason it's doing this is because we already have one. Otherwise, it would go up here. And if we, and otherwise it would, yeah, it would only do this one because it would prioritize the template over the other. And then finally we say, hey, double, we need a fucking new one, yo. Make me a new one. And in the debugger, it's not showing us that it actually exists. It's just going to run all the other unspecified or ungenerated specializations from the primary. It's not going to actually show us, hey, you compiled. Now there are these other guys in the translation unit, and now you're calling them specifically. Instead, it's just going to show, hey, you're calling this guy, and then shit happens. It handles the rest. Cool. Yeah, it makes sense. Cool. Oh, and if the bottom case results in, well, yeah, it makes sense. Well, yeah, because in this case we have a specialization and this, so yeah, it'll prefer that. Oh, because he wasn't saying that initially. So we're saying if we're doing the template way, it will only consider the templates. But if we do it this way, it will consider templates, and because of template argument deduction, and which is also happening here too. But this will consider all possible options slash functions slash overloads. And it will prefer the non-template ones. That way we can fucking call overload, or the overloaded non-template one, without having to fucking use a damn function pointer or something. Man, I'm cussing too much. Let's just say a fucking damn. I need to chill. The bottom case results in both that are equally viable. Non-template will be preferred. Makes sense. Normal function call prep syntax will prefer a non-template over a template. Makes sense? Yes. For example, in this case, I don't want to see this. Okay, so we have max int. So we're going to say, hey, either explicitly make an int one or call the int one. Do we have an int one? No, we do not. We simply have a regular little overload, and we have the primary template. Make an int one, motherfucker. Oh, only consider int or template ones. Make one. Oh, one already existed. Use that one. Oh, consider everybody, but focus on regular overloads. Okay, we have a template, but we also have an overload, a regular one. Boom, call that. Max int. This guy. Yes. But in this case, we're explicitly saying, hey, here's the int one. Here, we're saying, hey, because of 1 and 2 both being ints, do the int one. If this is a float and a double, it would say, hey, look for a float and a double one. Oh, we don't have one? Make one, motherfucker. But in this case, it wouldn't work because we don't have 2 type names that are different types. Okay. I'm going to chill for a sec. That's 45 minutes. And then I'll start again. I think that's how I'm going to do it. I'll do 2 15-minute breaks, one between the first 2 little study sessions, and then another between the study session 2 and the self-test. That way the brain can do shit in the background. All right, cool. And I got to do my laundry too.